Hello, welcome to our example 4. So this will be our example 4 of Bernoulli. So please make sure you watch all of these previous videos on Bernoulli and that will help you. This time we have a initial condition. So we'll take care of that later. So just find the general solution first. This one already in the correct format. So you can see this is the P and this is the Q and N is 2. So that's good. This is already in the correct format. So let's actually solve, find the general solution, and then use the initial condition to solve for C. Geometrically, the initial condition means when x is 2, y is 1, y is negative 1. Or the graph must go through the point 2, comma negative 1. Okay, so let's proceed. So you start with the substitution. V equal to y to the power 1 minus n. Here n is 2. So let's continue. Y to the power 1 minus 2 or y to the power minus 1 or 1 over y. So let's take the derivative of both sides with respect to x. So I get dv dx. The derivative of y to the power negative 1 is negative y to the power negative 2 times dy dx. Chain rule, right? Solve for dy dx. So you multiply both sides by negative y square. So this will be 1. Let's continue. So I have negative y square dv dx equal to dy dx. So in place of dy dx, I have to substitute this. So my dy dx is something to say y prime. So y prime is something to say dy dx, of course. So let's do that substitution. So in place of y prime, I substitute this. So let's do that substitution. So let's write it here. So in place of y prime, I write negative y square dv dx. And I copy everything else. So let's copy everything else. So I have plus 4 over xy equal to x cube y square. So at this point, we have x, y, and v. But we need to get rid of y. How we do that? We have to make the coefficient of dv dx 1. So I multiply both sides by negative y to the power negative 2. So let's do that. So I have to multiply each one. So the first one, they'll make it a 1. So negative times negative is positive, and y to the negative 2 and y square is 1. Y to the power 0, which is 1. So all I have is dv dx plus, actually negative, because negative times positive is negative. So I should have a negative here. And because this negative and positive is negative, right? And then I have a 4 over x. Let's copy that. And then y to the power negative 2 and y to the power 1, of course. It's just y to the power negative 1. You add the exponent when you multiply. Equal to, here I have to have a negative here, x cube, because y square and y to the power negative 2 is 1. And this is still I have a y. y to the power negative 1. But remember the substitution. Y to the power negative 1 is actually v, right? The v is equal to y to the power negative 1. So that's the last thing I have to do to make it a linear. So in place of y to the power negative 1, I substitute v. So let me rewrite what I have now. So I'm going to write here. So after the substitution, I have dv dx minus 4 over x v, because y to the power negative 1 is v, equal to negative x cubed. And this is linear. And v play the role of y. So v is the unknown function. So let's apply the method of linear. So of course here p is negative 4 over x and q is negative x cubed. Don't confuse this p and q with the p and q of the Bernoulli. In this case, p and q represent the linear part. So let's start with finding the integrating factor. So u is e to the power integral of p dx. So let's do that. So it's going to be negative 4. I can bring it outside. And the integral of 1 over x is ln of x. I'm just going to put the absolute value. I can bring that exponent, the number in the exponent of the ln. Remember, that's one of the properties of ln. So I get e to the power ln of 1 over x to the 4, because x to the negative 4 is 1 over x to the 4. And because the exponent is an even number, 1 over x to the 4 can never be negative, right? It's always positive. So I can drop the absolute value. So this is just e to the power ln of 1 over x to the 4. Because 4 is an even exponent, so I can drop the absolute value. It's an even exponent, it always positive. So I end up with just 1 over x to the 4. Because e and ln are inverse function. So they cancel each other. Very good. So that's the integrating factor. Now let's find the v. So the formula is integral of u times q divided by u. So let's substitute. So integral of u is 1 over x to the 4 times q is negative x cubed divided by u, again, is 1 over x to the 4. So let's do the calculation. So I get v equal to, so when I have the negative, so this negative I can bring it outside if I want. So I get negative integral of 1 over x to the 4 and x cubed. That's just 1 over x. And you can see this x cubed, I can cancel, and I have x in the denominator, right? Just 1 over x. And I put this negative outside. And I have a 1 over x to the 4. Let's copy that. So let's continue. Equal to, now the integral of 1 over x is ln x. So I get just negative ln x. Now if you want, you can put the absolute value. So I get negative ln x plus c. Here you have to add c. And this 1 over x to the 4 I can copy. And of course I can flip it. So this I can flip it here, right? I can put it in the top. So 1 over x to the 4, I can flip it, and then I get x to the 4 on the numerator. and I get that. So finally, I have to rewrite what is my v. So let's go back and check my v. The substitution that we make is v is y to the power -1 or 1 over y. So let's do the substitution. So my v is 1 over y equal to, and then I copy this. Excellent. So that is the general solution. It's still implicit because we have not solved for y. So it's still general implicit. It is not a requirement that you always make an explicit solution, but whenever possible, you can do that. And in this time, of course, it's possible, but we'll do it later. Let's actually find out the C using the initial condition. So let's go back. The initial condition is y of 2 equal to -1. So let's use this initial condition that y of 2 is equal to -1. So when x is 2, y is -1. So let's substitute y -1 and x 2. So I'm going to substitute y as -1 and x is 2. You can use a calculator if you want. So this is 16. So let's divide both sides by 16. I mean, this is just -1. So I'm dividing both sides by 16, right? So this cancel out. So just simple arithmetic that everybody can do it. So I'm going to drop the absolute value and then just solve for C. So if I solve for C, I get ln of 2 minus 1 over 16. At the end of the day is some number. And you can use a calculator to approximately find the decimal, which I'll not do that. And then finally, I have to replace the C here, in here. I can replace C by that number. So let's replace the C here by that number. Right there. So let's copy everything else. So I get 1 over y equal to x to the 4 times negative ln of x to the 4 times negative ln of x plus c, but my c is this. And how can I make it explicit? You just flip around. So if I flip, I get y equal to, and all of them goes in the denominator. So 1 over that whole thing. And that's it. That's an explicit specific solution. And that will be my final solution. Never forget that you can do it. Always believe in yourself. Thank you. Bye bye.